morning, good afternoon, good evening, ladies and gentlemen. And I'm here, Muhammad Nabil bin Muhammad Nizam, to present my engineering maths project. So let's get right into it. Okay, for the first question, I'm supposed to solve the equation y equals to x to the power of 2 plus bx plus c. So for this, I just key in the formula, which is this, but I use the second bar, the second column, as my the first number, plus b, which is over here, times x, which is over here, and then plus c, which is over here. Then it will just automatically calculate, and then you'll get negative 10. So I'll just put the formula to each and every one of this row. So question 2. Display both curves on the same graph using table values. Second graph to change with different inputs B, C. So this is the blue one is input. The blue one is y equals to x squared, while the orange one is y equals to x to the power of 2 plus bx plus c. So as you can see, they're not this like they only intersect at one point, and when I change the values of B and C, it will also change. As you can see just now, the graph was didn't start at point 20 at first. It started at like below that, right? But now, when I changed to 2, the graph changed. Similarly, like input C, I'll change to value 3, it will change. Now that looks fairly similar, so I'm going to change to a bigger number, so it'll make it obvious. Alright, so it clearly didn't start at the same point previously, so now it did. So that proves the point that the different number of values of B and C will definitely change how the graph looks. Question 3. So for this equation, I just put the equation, the discriminant equation, which is b squared minus 4ac. B squared is b over here. I just put f4 times f4, which is basically b squared. Or maybe I could just put it over like this, which makes it easier. Minus 4ac, which is 4, and then times a is 1, so I don't really need to put that, and times c, which is h4, and then you'll get 36, negative 36. For this, well, some of the solutions here are like like you see that if the values are too small, it's like the solutions are not um, it's like a math problem. Like you won't really get a decimal number, you'll just get a error. So at some point, like the number of B and C's, it will get to a point where if it's low, if it's too low, it will show an error pop up. So for this, I'll just use the minus b plus square root b squared minus 4ac over 2, that formula, but I'll just solve in the b as f4 and c as h4, which is over here. As likewise is the same as this, but the only difference is instead of minus b plus square root, this one I put minus b minus square root. Okay. For question 4, okay, so since b is in the bracket over here, it causes the graph to move left or right. But because of c and b, here c and b are outside the bracket, it will affect the graph by moving it up or down. So c will affect it by its coordinates, while b will affect both x and y coordinates. For question 5, likewise in the discriminant, when I change the number, let's say number 9, it will change. So for this, likewise for this question, for the discriminant to change, the values b and c will need to change as well. So for that, um, the discriminant will change if the numbers b and c will change. Alright, so for this one, it really doesn't, you can't really tell where, if the discriminant will affect it by moving up or down, but it will definitely move if the number of the numerical discriminant is changed. So you can tell maybe a slight difference or a difference, big difference, but for all we know is that if the discriminant is different, the graph changed. Okay, and that is for all for my engineering maths project. Sorry, assignment, and Muhammad Nabil signing out.